Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. The subject is matrices and calculus. Today, we are going to discuss about the topic on the double integral in constant limits. That means here the limits are one is the constant limits and variable and also the polar coordinates. But here we are going to discuss about on the double integral in the constants limits. And here, first of all, we need to understand what is the meaning of the integral, and again what is the meaning of the definite integral, what is the meaning of the indefinite integral, and again under the limits, here if it is a double integration and again the triple integration, like the number of the integrations are available. But here first we discuss that about the integral. Here the integral is usually called as a antiderivative because integrating is the reverse process of the differentiating. This is called as a simply the integral. Here the integration can be used to find the areas, volumes, central points and many useful things. Here we need to understand what is the meaning of the definite and also indefinite integrals. Here when we are going to observing this diagram like the graph of this one, here clearly the definite integral is nothing but the particularly limits are one of the limit is existed, the other limit is does not exist the condition. That means while we are going to observing here, it is clearly indefinite integrals. That means it is a lower limit is existed and again the upper limit is not existed. Sometimes the lower limit is not existed, the upper limit is existed. That means any one of the integral, the limit is not existed, that is called as a indefinite integral. And other side, if you are going to observing this is the diagram like the graph of the part, here clearly particularly in this the lower limit as well as the upper limit, both the limit are it is existed. That means it is clearly the meaning is the definite integral. And based upon this definite integral and again the indefinite integral, we are going to discuss the further continuation part. Here, first we need to discuss what is the double integral by the integration part. That is the meaning of the direct integrations. Here, what is a double integral? First of all, we need to understand what is the meaning of the double integral. And this is also under the multiple integral. One of the part is a double integral. The double integral is nothing but the integrals of a function of two variables over a region in R square is called the double integrals. And other one, for example, the double integration of a function of two variables, that is a function is involving x comma y. For example, if it is assumed that over the region R in the R square is the double integration R with denoted f of x comma y, that is a area particularly, and again is equal to the double integration R f of x comma y, and here particularly the function is involving that x comma y. That means the integration with respect to dx and dy, and dx comma dy is also sometimes depend upon the dy and also dx. That depend upon the given like a definite integral, we need to interchange like the dx and also dy and again the dy and also the dx. Here, today our topic is based upon the double integral with constant coefficients. That means if the limits are involving the constant limits, then how to find that is a double integration part. For example, the limits are, for example, it is the two integrations are like the double integration it is called. The limits are, it is one is a to b and again the other limits are the like c to d. That f is a function involving x comma y, and again here we are doing the with respect to that is a dx and also dy. While we are going to observing here, the limits are particularly that all the limits are constants. That means here a comma b and also c comma d, these are the limits are under the constant limits by taking. Here if the inner limit is, if you are going to do the integration part, one is we need to observe that what is the inside of the variable. That means here clearly it is showing the dx. That means we need to find the integration with respect to x, and again the limits are assumed that c and also d. first of all, we need to calculate the part of the inside of the integral part. And again, after that simplification, if we get the value is treated as something whatever it may be, that is a z of y, that g of y can be replaced in the inside of the integration part. And again, after that, you need to find out with respect to the rest of the thing, that is a dy is a condition. That means while we are going to discuss that in double integration, first of all, we need to discuss we do that the inside of the integral with respect to dx, and again after that simplification, then only we need to do that integration with respect to y. Here, whenever these are the particularly the limits are, it is a constant terms. And similarly, same, for example, that is limits are c and also d, and again that a comma b. That means here integrating first we need to with respect to dx, and after that with respect to dy, and otherwise that is the meaning of it is treated as x is equal to c and d f of x comma y into dx, and after that integrating with respect to dy here. And other side, for example, the limits are c to d, the function is f of x comma y into dy, and again after that dx. That means while we are going to observe in the previous one, that is inside the variable is with respect to dx, but in this the integral inside of the integral with respect to y, that means we need to integrating with respect to y, because of here the inside of the variable is a dy, that means the limits are treated as a y is equal to c to d, and again we need to do that integrating with respect to dy, that means that is a y variable, and after getting this one you need to consider that is z of x, that value can be replaced in presence of the inside of the that part, and again after that with respect to dx is the condition. Here this is the conclusion of that first integrating with respect to dy, that is the meaning of that is y is equal to c to d, and again after that x is equal to a, because of the inside of the variable is a dy, then you need to assume that dy is equal to c to d, and again after that with respect to dx. Yeah. Now here, note that the process evaluation is a iterative, that means first evaluate the integral with respect to dx, and after that dy, in case order of the integration is dx and also dy. That means while we are going to observe in the double integration, if the limits are all are the constants, one is the inside of the limits are integral with respect to dx, then integrating with respect to x, and again after that with respect to y. For example, the problems are given in terms of dx that treated as x is equal to a to b, and again after that simplification we need to find with respect to dy. And similarly, sometimes in branch of it is a double integration, that is a dy and also dx. That means first integrating with respect to dy and after with respect to dx. This is the mandatory to find the solutions whenever the limits are given the constants. That depend upon that we need to give the priority for the inside with respect to dx. If it is a dx is there, you need to find the dx, and after with respect to dy. For example, if you need to observe that the problem is x is equal to the limits are, first we need to observe the limits. The limits are, the lower limit is first one, that is 1 to 2, and again that second one the lower limit is 0 to upper limit is 1. Here the variable is a function is xy into that with respect to dy and also dx. And here while we are going to observing in this problem, here first we need to check the limits. Here all the limits are constants. But if all the limits are constants, and then at the same time we need to observe that what is the inside of the variable with respect to the condition. And here that inside of the variable is a dy, that means first we need to integrate with respect to y, and again after with respect to x. That means we need to assume that the inside of the limits are y is equal to that is a 1 to 2, and again the function is xy into dy and also dx. First we need to calculate what is the inside of the integral part, that is y is equal to 1 to 2, that is a function x comma y into dy. And again here when we are going to do that with respect to y, that x is a constant, you need to take that outside, that is x is outside, and again the rest of the thing is integration y to y is equal to 1 to 2, and again that integration in y, the integration of y is nothing but clearly y square by 2. And after that we need to replace that y is equal to that upper limit is 2, the lower limit is 1, as we know that how to find the integration by replacement of the limits, that is upper limit as well as the lower limit. Here after replacement of upper limit and lower limit, the value is 4 minus 1. Therefore here that 4 minus 1 is nothing but it is a 2 3 value, and again here that 3 by 2 is take out common constant. The rest of the value is integration 0 to 1, that is x into dx is the function. And again here with respect to dx is nothing but the limits are clearly it is x equal to 0 to 1. The integration of x is nothing but that is x square by 2. And again after getting that x square by 2, that is integration x equal to 0 to 1, it is x into dx. Therefore that is a 3 by 2 into x square by 2. The limits are 0 to 1. Again here also by replacement of upper and lower, and finally after that replacement of 1 by 1 that upper and lower, we obtain the clear solution is a 3 by 4 is a final solution. This is the procedure under the double integration. Whenever the limits are like constants, first we need to check according to what about the limits. If the limits are satisfied the constants, and again next we need to follow that according to with respect to integration inside of the part only. For example, we need to observe this case. Here the double integration under clearly the limits are 0 to 1, 0 to 2. The function is x into y and dy into dx. And here also the problem is clearly showing the under the double integration the limits are constants, and here also the inside of the function is that is with respect to dy. That means we need to integrating with respect to first is the y. That means here the limits are we need to assume that y is equal to 2. The integrating we need to do that x and also y function. While we are going to do that integrating with respect to y, here x is a constant, you need to take out common x is a constant. The integration value is a y square by 2, and again here also that upper limit and lower limit it is a 4 minus 0. That means 4 into 2 that is a 2. Therefore you take out common 2. The integration 0 to 1, the integration of x and integration of x is nothing but here also 2 into x square by 2. The limits are 0 to 1 and 2 to cancel. The solution is it will be clearly 1 is a solutions. Now we need to discuss one more like other problem. Integration 1 to 2, 1 to a and 1 to b dy and dx by that is a xy. Here also the problem is under the double integration the limits are all are constants. Here the inside of the function that is with respect to first given that dy, that means we need to do that integration with respect to dy. That integration dy is nothing but the denominator 1 by xy. Here 1 by x is a constants. By take out common 1 by x is outside. The rest of the thing is 1 by y. As we know that integration of 1 by y is nothing but that is a log y. Therefore 1 by x into that is a log y. The integration the limits are y is equal to 1 to b dx. And again here by replacement of upper and lower that is a log b minus that is a log 1. And here as we know that the value of log 1 is a value is a 0. Therefore the solution is log b, and log b is a constant by take out common log b, and here the rest of the thing is 1 to a, and again the remaining part is 1 by x into dx. And here also then 1 by x is the integration is log x. Therefore log b take out common and again log x. Again here also that x is equal to 1 to a. Therefore by replacement of upper and lower log a minus log 1. And here also log a minus log 1 is the again it is also the lower limit with respect to log 1 is 0. Therefore the final solution is log b into log a. And it is also clearly we can say that the limits are all are the constants under the double integration, that we need to observe that what is the integration inside of the part. And again first we need to do that integrating with respect to inside, and after that we need to do that integrating outside. For example, in this the problem is under the double integration with constant coefficients. The problem is that is a one is a 0 to a and other one is a 0 to b. x plus y into dx and dy. And here also based upon this concept, that is first integrating is dx. That means the instead of the limits we need to assume that x is equal to 0 to b, and remaining the rest of the limits are treated as y is equal to 0 to a. And here, while we are going to do that integrating first with respect to dx, and the first part is integration of x is there, therefore x square by 2, and second one, the rest of the integration part is a y, but we need to do that integration with respect to x, therefore y treated as a constant, the rest of the one, the integration with respect to x is a like x value. Therefore, by doing like according to this one, integration of 0 to a, and again that x square by 2 plus yx is the limits are x is equal to 0 to b and dy. Now, by replacement of upper limit x is equal to b to lower limit is 0, after replacement of 1 by 1, the value is b square by 2 plus by minus the lower limits are by replacement of x is equal to 0, the value is 0 minus 0 into dy. And here, after that simplification here, that b square by 2 by plus by is a value. Now, again we need to do that integration with respect to y. Here, the first part is a b square by 2. While we are doing the integrating with respect to y, that is a b square by 2 into y. Because of that b square by 2 is a constant, the rest of the thing 1 is a integrating with respect to y, and plus that b is take out common, y integration is a y square by 2 is a value. And again here also, after replacement of this integration, that again we need to replace y is equal to a. By replacement of upper and lower, the final solution we obtain that clearly ab into a plus b by 2 is a final solutions. And again, for example, the problem is that is a double integration 0 to a and 0 to b, x square plus y square into dx dy. And here also clearly the double integration under the limits are constants. The first inside of the part is that is a dx. That means we need to do that integrating with respect to x. While we are doing the integrating with respect to here, the first part is x square, that means x cube by 3, and again plus that y square, but we need to do that integrating with respect to x, therefore treated as a y square is a constant, that is a y square into 1 is integration is a y square into 1 is a y square x. That means according to here, the integration of 0 to a, and again it is a x cube by 3 plus y square x, the limits are x is equal to 0 to b and dy. Here also we need to replace the limits are x is equal to b and lower limit is x is equal to 0. Here the solution will be that is integration x 0 to a, that is b cube by 3 plus b into y square, and similarly the lower limit is 0 minus 0. And here the second term it is total is 0, the only the first term, that is a b cube by 3 plus by square. And once again we need to do that integrating with respect to y. The first part is b cube by 3 is a constant, the rest of the term 1, that integrating 1 is a y plus b into that is y square integration is y cube by 3, and again the limits are here, y is equal to 0 to a. By solving this, like means when we are going to replace here also that upper limit and lower limit in terms of y is equal to a to 0, the final solution here we obtain that ab into a square plus b square by 3 is the final solution. Now we need to observe other one, double integration 0 to 1 0 to 1 1 by under root of 1 minus x square into 1 minus y square into dx dy. Here also that problem is based upon under the double integration with respect to x and also y, under the limits are 0 1 0 1. That means one of the inside of the limits is treated as that is a x because of dx. It is not given the particular limits, therefore we need to assume that x is equal to 0 to 1, and rest of the thing we need to observe that with respect to y, that is y is equal to 0 to 1. While we are going to do that, this one, it is clearly showing the problem is that is a double integration, one is a integration x is equal to 0 to 1, the integration x is nothing but x equal 0 to 1 by under root of 1 minus x square into 1 minus y square. We need to consider that is a splitting into two parts, 1 by under root of 1 minus y square, 1 by root of 1 minus x square into dx dy. While we are going to do that, first one is with respect to dx, the integration of 1 by root of 1 minus x square, as we know that is a sine inverse x. Therefore, integration 0 to 1, that is a sine inverse, that is 1 by root of 1 minus y square is a constant. The rest of the thing, that is a sine inverse x by a. That means in presence of here a is equal to 1 only. Therefore, sine inverse x. Therefore, it is a 0 to 1, that is a 1 by root of 1 minus y square, sine inverse x, and again 0 to 1 into dy. While we are going to replace here x is equal to 1, the value is upper limit sine inverse 1 minus lower limit is 0, that is a sine inverse 0. Therefore, as we know that sine inverse 1, the sine inverse 1 is, that is a sine of, that is a pi by 2. That is a meaning of, it is a pi by 2 is a solution. Therefore, sine inverse 1 is nothing but it is clearly, that is a sine pi by 2, that is a meaning of, it is a 1 is a clearly pi by 2, sine pi by 2. Therefore, pi by 2 minus the sine inverse 0. The sine inverse 0 is nothing but the 0 is satisfied, that is a sine 0. Therefore, that is a pi by 2 minus 0 is a clearly the value. And here again the integration pi by 2 is a constant term. The integration 0 to 1 by under root of 1 minus y square into dy, and here also clearly by showing the direct integration, that is a sine inverse y. Therefore, upper limit here also 1 to 0. Therefore, pi by 2 into, in presence of this one also, that is a pi by 2 minus 0, that is nothing but pi square by 4 is a final solutions. Similarly, here also same like the sine inverse x, but here also sine inverse y. For example, this one, integration 0 to 3, 0 to 1, xy into x plus y into dx dy. And this is also clearly showing that the problem is under the double integration with respect to x and also y, the limits are all are constants. And here, the inside of the function with respect to dx, that means we need to do that with respect to x. While we are going to do that integrating with respect to x, here, the first term it is a xy into x plus y is nothing but x square y plus xy square. That integrating with respect to x is nothing but the first term is, that is a x cube by 3 into y. X cube by y into y. Plus the second term is clearly showing that x into y square, that is nothing but x square by 2 into y square. Therefore, the replace the upper limit is 1 and lower limit is 0 in presence of x. Therefore, the first upper limit is y by 3 plus y square by 2, and lower limit is clearly the value is 0 minus 0. And here the problem is 0 to 3, y by 3 plus y square by 2. Once again, we need to integrate with respect to y. That means it is the first term, it will changes to y square by 6 because of already existed, that is a 3. The 3 into 2 is a 6 plus the rest of the thing y cube by already existed 2. That means 2 into 3 is a, it is also 6. And based upon this one, it is a 1 by 6 take out common, y square plus y cube. And by replacement of upper and lower limit, it is a, clearly the value is, that is equal to, we obtain that 6 is a final solution. And next one, the double integration, that 1 to 2 and 1 to 3, x into y square dx dy. Here also the problem is clearly showing, that is under the double integration with the limits are constants. That means the limits are here clearly 1 to 2 and 1 to 3. The variable is, that is a function x into y square dx dy. And here also, first, while we are going to do that, integrating inside of the part, that is a dx, therefore, it is also treated as x is equal to 1 to 3 into xy square into dx dy. While we are going to do that, first integrating with respect to x, treated y as y square is a constant, therefore y square into, that is x square by 2 plus x square by 2 into dy. And here also replacement of x is equal to upper limit 3 and y, the variables like the function is y square by 2 is a constant, that is a 9 minus 1 into dy. Therefore, it is a 8 by 2, that 8 by 2 is nothing but that is a 4 into y square by is a value. And here also, like by using the simplification, that 8 by 2 is nothing but 4, and here the inside with respect to y, that is a y cube by 3, the limits are 1 to 2. Here also 4 by 3 take out common, the solution is 8 minus 1 is equal to, that is remaining the solutions. It is a 28 by 3 is the final solutions. For example, it is something different interesting problem, that is a double integration 1 to 2, 0 to 1, 1 by 2x plus 5y into whole square into dx dy. While we are going to discuss, this problem is under the double integration with constant limits. It is with respect to x and also y. But here the problem is 1 by 2x plus 5y whole square, and it is a integrating with respect to x is the inside, that we treated as the inside of the limits are x is equal to 0 to 1, and again the rest of the values are y is equal to 1 to 2. First we need to integrate with respect to 2x plus 5y whole power minus 2 into dx dy. That means with respect to x only. And here it is not possible to separate that y or x. Due to the reason, when we are going to do that integrating with respect to x, we need to treat it as a y is a constant, and based upon the constant observation, the 2x plus 5y whole power of n, that means we need to treat with the help of the formula like 2x plus 5y whole power of minus 1, because of integration, as we know that formula ax plus b whole power of n is nothing but ax plus b whole power of n plus 1 by, that is a n plus 1. And here the coefficient of x is the a, therefore that value you can replace in the denominator, that is a multiplication with a, that is a value. By using this one, it is n is nothing but in this problem minus 1, and again the denominator here x coefficient is a, but it is in this problem that x coefficient is a 2, and here b is nothing but 5y is the value. By using this problem, the solution is clearly the 2x plus 5y whole power of minus 1 by, that is minus 1 into 2. And here minus 1 by 2 is the take out common. The rest of the thing is 2x plus 5y whole power of minus 1 by replacement of that upper limit and lower limit at x is equal to 1. Clearly we obtain this is the value. And once again minus 1 by 2 take out common, that is a 2x plus 5y whole power of minus 1 is nothing but 1 by 2 plus 5y minus 5y whole power of inverse is nothing but 1 by 5y into dy. And here also clearly the problem is showing integration of 1 by, first we need to do integrating with respect to y, and 1 by it is in the form of 1 by a plus bx, and integration of 1 by a plus bx is nothing but that is 1 by b log of a plus bx. By using that formula, while we are going to replace in this, it is 1 by a, that means the coefficient of y is the 5, that we can divide 1 by 5 into log of 2 plus 5y minus 1 by 5y. That means minus 1 by 5 is a constant, the rest of the thing is 1 by y, that 1 by y is the integration is a log y. Therefore, minus 1 by y minus 1 by 5 into log y, the limits are y is equal to 2. By replacement of here also, that upper and lower, we need to take out common, 1 by 5 is a common, we need to take out common outside, that is a minus 1 by, based upon this one minus 1 by 5 take out common, already it is existed minus 1 by 2, that means minus 1 by 10 into log 12 minus log 2 minus log 7 minus log 1. By replacement of y is equal to upper limit is 2 and the lower limit is 1. And here also, as we know that the formula log a minus log b like that, by using the log a minus log b, we need to write like log of a plus b, like log of a by b like that. According to after that simplification, we obtain that clearly 0.1 into minus log 2, 12 plus log 2 plus log 7 is a final solution. For example, this one. The problem is under the double integration with respect to x and y. The limits are under here minus 1 to 1 and 0 to pi by 2. Here also the problem is clearly by solving that one by one, the inside of is with respect to, we need to assume that x, and again the limits are with respect to -1 to 1, and again that first we need to do that integrating with respect to x. That means it is a y is equal to, we need to assume that 0 to pi by 2, and again x is equal to -1 to, that is 1. It is y square is a constant. That x square integration is x cube by like x square into dx, and after that dy. And again here y is equal to 0 to pi by 2 y square, in integration of x square is a x cube by 3, the limits are -1 to 1 into dy. By doing after the replacement of this one, it is a 1 by 3, like 1 by 3, it is integration 1 by 3 take out common, y is equal to 0 to pi by 2, it is y square, it is 1 minus of the lower limit is -1 into, that is dy. 1 minus of minus is nothing but that is a 2, that is a 2 by 3 into integration of 0 to pi by 2, that is y is equal to, that is y square into the dy. And again after that we need to do that integrating with respect to y, and again here y cube by, that is a 3, the 2 into 2 by 3 is nothing but that is a 2 by 9, and again after that replacement of like upper limit and lower limit, finally we obtain the solution is clearly pi cube by 36 is the final solution. Like these are the some different type of the problems under the double integration. Whenever the limits are given whenever the variables are given under the double integration x and y, the limits are, all the limits are constants, we need to do according to such type of, this is the concept. That is a these are the clarification under the multiple integral. Whenever the limits are whenever we are going to discuss the double integration, under the limits are like constants, that is a comma b c d or other in any other terminology constants, we are going to give the priority. First we need to observe that whatever the inside of the function, either the x, we need to assume that x is the limits first, and again that integrating with respect to x also first, and after that simplification we need to do that with respect to y. And sometimes, for example, the problems are like dy and dx. That means we need to observe that first is with respect to y, that means treated as whatever the given limits are, if it is not mentioned, we need to give the priority. First is the inside with respect to y, and again after that finding the solution, again the rest of the things we need to assume that x limits and find the solution of the given problem. This is the clear concept involving under the double integration. Whenever the limits are constants, we need to do the problems like this. And again further, if any problems are like any facing in further, we need to discuss according to this the manner. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.